What's up, guys? We're going to evaluate the six trigonometric functions. So, have myself a triangle here. It is a right triangle. And we're going to evaluate the six trigonometric functions of the angle theta. So, we have theta here. This is our reference angle. We have one side of the triangle and we have the hypotenuse. So, in order to do the six trigonometric functions, we're going to need to know all three sides. So the way we're going to do that, and this is a little bit of you have to remember back to geometry, is we're going to use the Pythagorean Theorem, which is a squared plus b squared equals c squared. And we're going to use that to figure out our missing sides. So remember, a and b represents the two side lengths, and c represents our hypotenuse. So really we have 6 squared plus b squared equals 10 squared. And we're going to solve this for b so we can find our missing side. So 6 squared is 36 plus b squared equals 100 when you square 10. So we're going to subtract 36 here, subtract 36 there, and we're going to have b squared equals 64. The only thing left to do there is take the square root of both sides, and we get b equals 8. So my missing side on this triangle over here is going to be 8. Now, I'm ready to go through my 6 trigonometric functions. I do have a video that talks about the 6 basic trigonometric functions. So if you need to reference that so you can go through those, you should probably do that before we go through the rest of this. So I need to know what sine of theta is. I need to know what cosine of theta is. I need to know tangent. And then I need to know cosecant, secant, and cotangent. So I'm going to fill out all 6 of these first, and I'm going to see if I could simplify any of them afterwards. So if we recall, sine of theta is always the opposite divided by the hypotenuse. So I'm going to have 8 divided by 10. Cosine is going to be adjacent divided by hypotenuse, so that's 6 over 10. And then tangent is going to be opposite over adjacent, so 8 over 6. Now I could simplify all of those right now, but hold off on that. You're going to make your life a little bit easier. Let's fill in all 6 of these first, and then we'll work on simplifying. So if we remember, the cosecant is always the reciprocal of sine. So we're going to have, instead of 8 over 10, we're going to have 10 over 8. Same with secant. Secant is the reciprocal of cosine. So we're going to have 10 over 6. And then for cotangent, that is the reciprocal of tangent. We're going to have 6 over 8. Once I have all 6 trigonometric functions filled in, that's when we're going to start trying to simplify these fractions, see if we can reduce. And what we're going to see on this example is all of them can reduce. 8 over 10, that's going to reduce to 4/5. 6 over 10 is going to reduce to 3/5. Tangent, we have 8 over 6. That's going to reduce to 4/3. And I'm going to take care of these 3 over here. 10 over 8 is going to reduce to 5 over 4. 10 over 6 is going to reduce to 5 over 3. And then 6 over 8 is reducing to 3 over 4. And that is our 6 trig functions. So that is how we evaluate when we are given the triangle already. So let me show you one more example. I'm going to get a little bit more complicated. So we have in a right triangle. So I don't have a right triangle yet, so I'm a visual person. So let's draw a right triangle. Theta is an acute angle, so I'm going to put theta here. I could have chosen to put theta there. Doesn't matter. But sine of theta equals 8 over 11. Evaluate the other 5 trigonometric functions of theta. So I know sine of theta already. I know sine of theta equals 8 over 11. Now remember, when you take the sine of an angle, that is opposite over hypotenuse. Opposite over hypotenuse. So I know the opposite side is 8, and the hypotenuse is 11. So I now have myself a triangle with 2 of the sides filled in, but I'm missing the third side. So I'm going to have to do a little bit of work here to find my missing side. So this is now very, very similar to the first problem on the other side here. So I'm going to use the Pythagorean Theorem, a squared plus b squared equals c squared. So that's going to look like we have 8 squared plus b squared equals 11 squared. 8 squared is 64 plus b squared equals 11 squared, which is 121. So I got to solve this for b. So of course we're going to try and get b alone. So we're going to subtract 64. And I'm going to get b squared equals 57. Well, to get b all alone, take the square root, take the square root, and we get b equals, and we're going to try and simplify the square root of 57. We cannot break that down, so we're going to leave that as the square root of 57. I'm not going to go to a decimal at this point. I want something exact. So I get square root of 57 is our missing side length. So now I can go through and complete the other 5 trigonometric functions. So I have my complete triangle there, so I still need to figure out cosine theta. I need to figure out tangent of theta. I need to figure out cosecant of theta, secant of theta, and cotangent of theta. So I'm going to start with my first 3 basic ones, and then I'll fill in the others. So let's fill in all 6, and then we'll worry about simplifying. So cosine, again, that's going to be adjacent over our hypotenuse. So I'm going to have square root of 57, square root of 57 divided by 11. Tangent, I'm going to have opposite divided by adjacent. So I'm going to have 8 divided by the square root of 57. And then to find cosecant, secant, and cotangent, we're going to take the reciprocal of each of these 3. So we're going to flip them all. So I'm going to have 11 over 8 for cosecant. For secant, we're going to have 11 over square root of 57. And cotangent, square root of 57 over 8. Only one last piece we have to do. We have to try and simplify here. Now, the simplifying on these 6 isn't as obvious. The thing we cannot have is we're not allowed to have square roots in our denominator. We cannot have an irrational number like square root of 57 in our denominator. So here's how we're going to do it. I'm going to show you the math of it down below, and then you'll find that most students go a little bit quicker on simplifying these. So if I had 8 divided by the square root of 57. Here's how you rationalize the denominator. What we're going to do is take that square root that we don't want on bottom, and we're going to multiply the bottom by the square root of 57. See how it matches up there? But if we multiply the bottom, we also have to multiply the top. Now here's the mathematics on what is going on here. Up top, when you multiply, I have a number on the outside and then the number on the inside of the square root. Can't mix and match those, so you're going to have 8 square root of 57. But on bottom, I have a square root of 57 and a square root of 57. Both numbers are inside the square root. So you could take 57 times 57, which that's going to be 3,249. So really I have the square root of 3,249. But on top, nothing you can do there. You get 8 square root of 57. But on bottom, when you take the square root of 3,249, you get just plain old 57. So this is the mathematics of what's going on here. But what most kids are going to do, and up here, is they're going to multiply the bottom by square root of 57, multiply the top by square root of 57. And they're going to know that on top you get 8 square root of 57, and on bottom we get just 57. You're going to have to ignore that announcement in the background. And then over here, we can do the same thing. We can multiply the square root of 57, and we can multiply the top by the square root of 57, and we get 11 square root of 57 over 57. And that is our 6 trigonometric functions here, 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 here.
So congratulations.